almost done. I'm waiting for you. I need the sum square of every observations here. If you don't do, so I can't continue. I leave it for you. Are you doing the exercise? So 625, is it right, the other student? You need to participate with me, okay? Okay, thank you. Let's continue. I use your friend's solution. 625, 625, okay? So in this case, we already have the sum, the total sum, equals to 383. So we have HHD, very easy. It's just the sum of YIJ square minus the total sum on square over the total number of observations. So here we have 625 minus 383 square over 24, and tell me the value. So 1, 2, okay, anyway, give me the decimal values. I just we are just doing the exercise, so just round it into 4 decimal places. It's okay. Okay, 512.9583. Okay, thank you. Now we have HHD, so we can choose to find SHE or SSB. Then we take HHD minus, then we got the order. Okay, as usually I will choose SSB. It should be easier. So I choose to find SSB. We have SSB equals to, I return to the formula for you. SSB, again, we have 2 formulas, the original formula and the computational formula. See, using the computational formula, we have HSB equals to the sum of yi dot square. It means that the square of its sum of the treatment. So treatment 1 we have sum of treatment 1, treatment 2 we have sum of treatment 2, and so on. Here, the total sum we already have. Okay, so using this formula, or it will be the same if you use the first formula. Okay, it will be the same. It's just my habit. I usually do use the computational formula. So we have 1 over n, because we have the number of observation for treatments will be the same. So the sum of y1 square, the sum of y2 square, the sum of y3 square, and the sum of y4 square, minus the total sum over n. Okay, so in this case we have 1 over 6, the sum of the first treatment, we have 60 square plus 94 square plus 102 square plus 127 square. All of this minus the total sum is 3h3 square over 24. Okay, and tell me the value, please. HSB, I'm waiting for your answer. So 3h2.7917. Okay, now we're able to get HSE, the sum square error, equals to SSD minus SSB. Okay, and tell me the value. One 130.1667. Okay. Now we got HSB, MSB equals to HSB over K minus 1. So we have HSB is 3H27917. K minus 1 we have 3. And tell me the value. MSB 127.5972. Okay, thank you. Then MSE equals to HSE over Kn minus 1. So 130.1667 K is 4, n minus 1, we have 6 minus 1, we have 5, so we have 20. Then tell me the value. So 6, 5, 3, 0, 8, 3. Okay, thank you. Now we have enough information. The test statistic is F0 equals to MSB over MSE equals to, you already have the value here. Plug in the value and tell me F0. One 96053. Okay. So to get the rejected regions, we need the reticle value. The reticle value, the critical value is the upper quantile of the Fisher distribution, with the F1 is degree of the numerator. Degree of numerator is degree of MSB. Degree of MSB is E3. Degree of denominator is degree of MSE, which is 20. So we write 3, 20, and alpha is 0.05. Okay. To get this upper quantile, we need the table of Fisher distribution. Let I show you. Fisher distribution. Okay, scroll down. Remember that because the Fisher distributions, we have three variables, df1, df2, and alpha. So we don't have the unit table. We have one table corresponding to one significant level alpha. So you need to look up the corresponding the true table, the corrected table. Okay. So here, look at the table. Percentage p points of f alpha v1 v2 of the f distribution. Okay, this is the Fisher distribution. Okay, this is what we need. But look at the graph. We can see that the density function indicates the upper quantile for alpha equals to 0.25. No, it's not our case. We need alpha equals to 0.05. So scroll down, looking for the Fisher distribution table at alpha equals to 0.05. Okay, here alpha equals to 0.01. No, passes. Here alpha equals to 0.05. Okay, that's our need. Okay, then the table includes the first row indicates the decrease of freedom for the numerator, and the first column indicates the degree of freedom for denominator. Okay, we need the numerator is 3, so number 3 is here. Okay, I couldn't highlight this. Okay, number 3 is here, and then the denominator is the first column. We're looking for 20, so we have 20 and 3. The cross position, we have 3.10. Got this? Can you see? 3.10. Okay. Okay. So now return to the board. We write the critical value is 3.1. Okay. So we got the rejected equations. Equations is the critical value is 110, 2 plus infinitive. Okay, because we want that f0 is as large as possible, as I have shown you. Okay, so now what conclusion? We see that since f0 is 1960, okay, so f0 belong to rejected equations. If f0 belong to the rejected equations, we confirm that f0 is rejected. If f0 is rejected, we confirm that there is difference between the means of tensor space. Or equivalently, we say that the Harwood concentration affects the tensor spring. Okay, that's on. Finish the Anova model. Okay, is it clear? Any question? Okay, I let you a few minutes for break and also the time to finish this example. Then we still have the second sessions about the multiple comparison after Anova. Okay, 5 more minutes for your break. Then we will continue to finish chapter 7 together. Okay. If you have any questions, so turn on your microphone and tell me. Okay, let's continue. Almost done. Return to the slides. Okay, we have seen that using the Anova model, we are able to answer for the question whether the factor x really affects the taste of the output variable y or not. Okay.